So let's talk about factoring when it comes to the sum and difference of cubes and also higher degree polynomials. The first thing you need to know is if you see a power or an exponent raised to the third power, that is referred to as a cube. So the sum, of course, represents the sign that's in the middle. So here we have a plus sign. So that's going to be the sum of cubes. And cubes is plural because the first term and the second term both are raised to the third power. The second rule has the sign of a subtraction sign. So that is the difference of cubes. Okay, so the rule is if you see that your first and your second term both are cubed, or that I can take the cube root of the first and that second term, your answer will always be in the form of binomial times trinomial. The binomial will consist of one of the factors from your first cube root and one of the factors from your second term's cube root. Then you have to account for the cube. So if this is just one, I have to get the other two in my second set, which is going to be the trinomial. So a squared times a to the first is a cubed. So that's how you take care of that. The last term, you would do the exact same thing. So I already have 1b. So in order to account for that cube, I have to square it. The middle term, you are multiplying both terms a and b, and that's going to give you your ab. So the way this works in terms of your signs, and this works both for the sum and the difference, is it will spell the word soap, which means that same, opposite, always positive. So if my initial problem had a plus sign, that first binomial is going to also have a plus sign. The next sign will be the opposite sign, which is now subtraction, and then the last operation will be always positive. That's what SOAP means. So again, if I have a difference of two cubes, difference of cubes, then if I started off with the minus sign, my first binomial sign will be the same. So it's going to be a minus. My second sign in my trinomial will be the opposite, which in this instance is a positive. And then that last sign is always positive. All right, so that's what your answer will look like. Let's get started on this first example. So for me, you don't necessarily see that this is in the form of a cubed plus b cubed, but it is. If I can take the inverse of this first term, meaning this is cubed, if I can take the cube root of 8x cubed and then do the exact same thing with that second term, take the cube root of 125, which I can, that simply means that I can use this method and I will end up with a binomial times a trinomial, and my signs will spell the word soap. How do I do this manually? If I have 8, I'm asking myself, what number can I multiply times itself 3 times, because that's what my index tells me. I need it that exact same number or variable this many times to come out once. So 2 times another 2 is 8. And then your x to the third power is simply 3 x's. And now if I can do the exact same thing over here, then that means it qualifies to follow this rule. And I can 5 times 5 times 5. And in the calculator, all you have to do is the cube root of the cube root of 125. You may have to press your second or shift button in order to access this cube root. So what this ends up giving me is that first binomial. Well, where does that come from? If I am taking one of the factors from each one of my terms, so in this case, I'm taking a 2 and an x. I'm only taking one of them. You see, I still have something left. I'm going to bring that same sign down because, again, S stands for same. And now I'm going to take just one from my second term, which is 5. So I'm finished with my binomial. My second set is a trinomial. And if I wanted, I can go ahead and just put the signs in because I know it's going to be a negative and a positive. And now I have to account for the other two factors that will make up this 8. So 2 times 2 is 4, and then x times x is x squared. I know that I'm doing it right. If I double check my work, 2 times 4 is 8. X times x squared is x cubed. So far I'm doing it correctly. I'm going to go ahead and skip the middle for now and go ahead and go to the second set so I can get rid of that. I want to take, I've already taken that 1, 5, and now I'm left with 2. 5 times 5 is 25. That's my last term. So I told you the middle a few minutes ago is going to be when you multiply both of those together. So think M for middle, and multiply starts with the M as well. So that's how you can kind of remember what goes here. So 2x times 5 is 10x. So the answer for this problem is a binomial times a trinomial, 2x plus 2x plus 5 times 4x squared minus 10x plus 25. And again, it spells SOAP, plus, minus, plus. That wasn't so bad, was it? Let's try another one. This time the sign is going to be a subtraction sign, which means it's the difference of cubes. Same concept, the only difference is the signs. So it still spells out SOAP, same, because since this is a subtraction sign, this is going to be subtraction. Opposite, it's no longer subtraction, it's going to be a plus sign, and then always positive, so that's going to automatically be a plus. Now, the only difference between this problem and the one that we just did is I can actually factor out a greatest common factor. So you definitely want to do that first if you can. So factor out your GCF, which simply means I am dividing both terms by what they have in common. And I know that they both have 3 in common. When I divide something out, I have to put that in front of my parentheses. So I'm going to have a 3 outside. So now what's left over is that 81 divided by 3, which is going to bring down 27, and then x cubed, the sign minus 24 divided by 3 is 8. Well, the negative is already accounted for. At this point, I can now do my inverse of cube rooting. So that's what I'm going to do. I'm going to take, but also, I don't want you to forget this. Always bring down your GCF. That's all you're doing is just bringing it down. This is where you're doing the cube root. So the cube root of the entire term, 27x cubed, minus the cube root of the second term, which is 8. And again, this simply means what times itself 3 times will give me 27. And it just happens to be 3. 3 times 3 is 9. 9 times 3 is 27. And then x, we already know, you just write 3 x's if you're expanding this out. And in the calculator, again, you can just do the cube root of 8, or you can ask yourself how many, you can expand it out. What number times itself 3 times will give me this number, the radicand, which is 8. So once I complete my problem here, I'm trying to put it in this format, which is binomial times trinomial. My binomial is going to, again, I'm going to bring down that GCF. My binomial, which is the 2 terms, is going to take one of the factors from each term. That includes here, it has a coefficient and it has a variable. So I have to take both. So 1, then I bring down this sign because it says it's going to be the same sign. And now I take one of these factors, which is 2. So again, my binomial is done. Now I go to my trinomial. And so that I don't forget, I'm spelling the word SOAP, same side, same sign, opposite sign, and then always positive. So just go ahead and put your sign so you won't forget. Now what you want to do is go back and account for your other factors that you left, your other factors. 3 times 3 here is 9, and then x times x, x squared. I, again, jump to the last one. So 2 times 2 is 4. And now the middle starts with m, so I want to multiply. So 3x times 2 is 6x. And now I am finished. But again, don't forget, even if you have to draw your little arrows like I did, don't forget to bring that GCF down, okay? You can't tell me that you're not getting this. This is pretty simple now, right? Okay, let's go on to the next one. Let's make sure we can see that squared here. Here we go. All right, so the next one, example 3, we're going to move on to like a higher degree polynomial. You'll notice it's no longer visibly the sum or difference of the two cubes, but it doesn't mean that it can't be once you start simplifying. So that's what we're going to do. We're going to first factor out the GCF. So when I factor out my GCF here, I notice that I can take out, this time, not only a number, but a variable x squared as well. So 2x squared is what's going to come outside of my parentheses. And I have to keep up with that. All right, so now once I simplify, I end up with 2 divided by 2 goes away, and then x to the 5th divided by x squared, you simply subtract your exponents, x cubed, bring down the sign, minus 16 divided by 2 becomes 8, and then x squared divided by x squared goes away. So, well, look what happened here. I now have a cube for my first term, and I could do the cube root of this second term. So I can use that rule that will allow me to end up with an answer that has a binomial times a trinomial. My first sign will be the same, since it's subtraction. My second sign will be the opposite, and then my third will always be positive. So again, I'm spelling out SOAP, S-O, always positive. So now let's go ahead and continue simplifying. When I simplify, and again, I'm just bringing this down constantly, 2x squared, I'm going to take the cube root of this x cubed minus the cube root of 8. And then I am going to, if I want to expand it out, x times x times x, 2 times 2 times 2, just so you can see it. I mean, some people see it already, but for those who don't. And then I am going to write it over to the side this time. So 2x squared, and parentheses, which is just going to be my binomial. I take one of those, which is x, take one of those, which is 2, and then the sign that's in the middle is the same. So that's what I'm working with so far. Now, I could go ahead and fill out the rest, but I do want to show you another way that you could possibly do this. You could actually use synthetic division now. So we're going to set that up. And I'm using a synthetic division so that I can find this trinomial. I already know the signs are going to be positive and positive, but let's see how we can do that. What I would do is, now this is my divisor now. So remember in another video, we talked about how you would just solve for x. Whatever that x is, that's going to go in your backwards L. So this will be positive 2. Now, my original problem is x cubed minus 8. So that's what I'm using for my coefficients. X cubed, the coefficient is 1. I have to account for x squared and x. Since they're not there, I've put a 0 placeholder. X squared, x, and now I have a negative 8. Now we can do our steps that we know to do. We start with the first coefficient, bring it down, and then we multiply everything times the divisor that's underneath this line. Okay, and then everything above it, we add. 1 times 2, you put your answer above, which is 2. 0 plus 2 is 2. 2 times 2 is 4. 0 plus 4 is 4. 4 times 2 is positive 8. And I realize I do not have a remainder. This will be my remainder if I had one, but I don't. Okay, Now I take this information, and that's what's going to go as my trinomial. I just have to replace the variables in it. So since I started with x cubed, that means this will be x squared. We already know that's plus. This will be x, and this will be a plus 4. I take this information, and I just put it in for the trinomial over here. X squared, 2x, and plus 4. So that's another way, if you wanted to use your synthetic division to find that trinomial, to double check your work. X times x squared is x cubed, and then negative 2 times positive 4 is negative 8. And then you can distribute it all the way out, and you'll see that it's going to end up canceling that middle term, and it'll end up just being this x cubed minus 8. So I just wanted to show you that way as well, in case you wanted another way of doing these type problems. And then our last example is going to consist of higher degree, which will turn into a difference of 2 squares. So when you see this type problems, especially if it's a 4 and as your first exponent and then it goes down by 2, me personally, what I do is I just divide both exponents by 2. And when I do that, dividing 4 by 2, I end up with x squared minus 6x, because 2 divided by 2 is just 1, plus 5. Now this is recognizable. Now you know what to do. And you're going to put it in factored form, which is saying, well, first off, x squared we know is just x times x. If you know the pattern, if you have a negative and then a positive, then both signs are going to be negative. If you don't know that, just go back to the rules of setting up your a times c, which is 1 times 5, and ask yourself, what two numbers can I multiply that will give me 5, but when I add them will give me negative 6. So that's going to be negative 5 plus negative 5 plus negative 1 will give me negative 6, which is what I need here. And then negative 5 times negative 1 will give me positive 5. So I know that's what's going inside of my, I don't know why I want to write a 5 there. Okay, so that's what's going to go into my binomials. However, I have to remember that I divided both of these by 2. So now I have to add those 2's back. Why am I doing that? Because my original exponent is 4. So x squared times x squared has to give me x to the 4th. So I know this is correct. Now I have to finish factoring. And there's something called the difference of 2 squares, where if I can take the square root of both terms, then my answer will be in the form of a plus b times a minus b. Remember, square root is a plus or minus. Remember how I told you all that? So that's what's happening here. I can't take the square root of 5, so I'm finished with that one. So I'm just going to bring that down, x squared minus 5. However, I can take the square root of x squared, and I can take the square root of 1. Again, expanding this out is x and x. Expanding this out is 1 times 1. Because it's understood that there is a 2 right here. A few minutes ago, it was a 3. This is telling me I need 2 of the same things to come out of my radical. And the 2 of the same things have to multiply to give me what's already under the radicand. So my final answer in this problem would be x squared minus 5. And using this rule, I'm going to take 1x here, which is represented by a. I'm going to take another x, so that one goes there, and this one goes there, and then I'm going to take one of those 1s, take another one of those 1s, and I'm going to use the signs that's in my rule, plus and minus. That is my answer for this problem. And so that's how you do, that's how you factor using like sum or difference of a cube, and also for higher degree polynomials. All right, you guys.